So now we're going to review the sine law. So why do we need the sine law? So we need it because the Pythagorean theorem, sine, cosine, and tangent ratios are used for right triangles only. So for any other triangle, we're going to use either the sine law or the cosine law. So right now we're starting with the sine law. And the sine law states that if you take side A and divide it by the sine of angle A, that's the same thing as side B over the sine of angle B, which is the same thing as side C over the sine of angle C. So those are what we call equivalent ratios. Or we can just take and flip the whole expression and have sine of angle A over side A, sine of angle B over side B, and sine of angle C over side C. And this works only if we have vertex C here, and opposite vertex C, we have side B. Vertex B, opposite vertex B is side B, and vertex A, opposite vertex A is side A. So let's review how to use the sine law to solve for a side length. So for example 1, we are going to solve for the indicated side x. What we need to do is set up our ratio, so same as all our other examples. So we're going to label our diagram, state the formula we're going to use, or state the equation we're going to use, and then solve. So let's start by labeling. And in this case it doesn't matter what we call A, B, or C. For our vertices, just remember that this will be side C based upon our diagram, and this will be side B. So when I use the sine law, I like to think of two things. What's my unknown ratio and what's my known ratio? So I always start with the unknown ratio. And if I'm looking for a side length, I'm going to use this formula here. So this one I'm going to use for side lengths because the side is already in the numerator and it's going to save you one extra step. So I'm looking for side B, so my formula is going to be B over, if I look at the formula, that's B over sine of B. That's what I call my unknown ratio. And then I need a known ratio, a side and an angle across each other. I have side C, which I know is 21, and I know angle C, so that's sine of C. So this I call my known ratio. The things I know. Alright, next part is to sub in and solve. So let's sub in our values. So side B is x. It looks like we don't know sine of B, but we do know that if I want to find angle B, that's 180 minus 100 plus 65. And 180 minus 165, that gives us an angle of 15 degrees. So we have x over the sine of 15 degrees. That's what goes right here. And now we set up our known ratio, and our known ratio is 21 over the sine of 65 degrees. Next we need to get x by itself. And right now it says x divided by sine 15, so our opposite operation is to multiply both sides by sine of 15. The sine 15s cancel each other out and become 1. And what I'm left with is x equals 21 sine 15 over sine of 65. And now the rest is calculator work. So you'll take out your calculator, type in 21 times sine 15 divided by sine of 65. And I end up with 5.997, so approximately 6.0 centimeters. That is the length of side x. So let's try this one more time. If you want, pause the video, try it yourself, see if you can find the value of x. Then come back and check your work. So again, first step, let's label our diagram. So let's say this is A this time, this is B, this is C. So we're looking for side little a. We have side C. And we have angle A and angle C. So let's set up our unknown ratio first. Remember, we're going to start with the side length in the numerator. So the side length we're looking for is A, and that means it's over sine of angle A. And the side that we do know is C, so that means we're going to divide by sine of angle C. So there is our known ratio. Next, we sub in our values. So we have A, which is equal to x, over the sine of angle A, which is equal to 30 degrees. And then we have C, which is 15, divided by the sine of angle C, which is 70 degrees. Same as before, we're going to multiply both sides by sine of 30, which means these cancel each other out. And we're left with x is equal to 15 sine of 30 over sine of 70. And all we need to do is type that into our calculator. So I end up with 7.98, which means it rounds up to approximately 8.0 meters. So that's how to find a side length. In our next example, we're now going to use the sine law to find angles. So it's the same thing. We're going to label our diagram, state an equation, and then solve. So let's start by labeling our diagram. A, B, and C. So we know our 13 is going to be side A, our 14 is going to be side B. Our unknown angle is here, angle A. It's the one that's indicated with the theta. And if I'm going to use the sine ratio, I'm going to start with the angle in the numerator. Since our unknown is angle A, I'm going to start with sine of angle A. And then that means I have to divide by the length this time. That's the second version of the sine law. Then I can see my known ratio is the sine of angle B over the side of B. Next, let's sub in our values. So we have the sine of A, which is our unknown. Angle A is unknown, or theta. If we want, we can put theta in that spot. And side A is 13. On the right side, this is our known ratio, so we know both angle B and side B, which is 14. Same as the last example, we have sine A divided by 13, so the opposite of dividing is to multiply both of these by 13. And I'm left with that sine A is equal to 13 sine 62 over 14. So the only difference between this and the previous examples is we have one more step. We need to find the angle, and right now all I have is the ratio. So to find the angle, remember we have to undo the sine. So to undo the sine, we're going to do the sine minus 1 of 13 sine 62 divided by 14. And if you have a display calculator, you should be able to type this all in at once and get your answer. So remember, to get sine minus 1, we're going to hit the second function button, or the shift button, and then hit sine. And then we're going to type in 13 times sine 62. And make sure to close off brackets where necessary. And then divided by 14. And then close off the bracket. So I end up with approximately 55 degrees. So just as a reminder, on my calculator, I had to hit the second button first, and then I had to hit the sine button to get that sine minus 1. Mine automatically had a bracket to start, and then I typed in 13 times sine, and then I had a bracket here of 62, closed off that bracket, divided by 14, and closed off the last bracket, and then hit equals or enter. And this is what I typed in order to get this answer. Right. So once again, here's another example to find an angle. So pause the video, try this example yourself, and then come back and check your work. So again, first step, let's label A, B, C. So this will be little c, this will be little b, and we're focused on this angle here. So that's our unknown. Since we're solving for an angle, I'm going to start with sine of angle C in the top over side of C. And then the ones I know, looks like angle B, so sine of angle B over side of B. So we have sine C divided by side C, which is 90, equals sine of angle B, which we have is 50 because this is our known ratio, so we need to have both bits of information, and side B is 100. Again, if we follow the steps, the next step is to multiply both sides by 90 because the left side says divide by 90, so the opposite is multiply. And now we have sine of angle C is equal to 90 sine of 50 degrees divided by 100. Remember, we're looking for an angle, so this is where we have to do the sine inverse, or the sine minus 1 of our answer. And only when we look for an angle do we use this sine minus 1. Again, let's type that into our calculator. And this time I end up with angle C is approximately equal to 43.6 degrees. Don't forget your units. So what we've done is we've looked at the sine law. If we want to find a side, we use this first version here. If we want to find an angle, remember, it's best to use this version of the sine law. That is because on the side version, the side is in the top, and on the angle version, the angle's in the top. So last part, when should you use the sine law? Well, there's two key factors here. First one, when we have a non-right triangle. That's the best time to use a sine law. However, you also need to have a known angle measure across a known side length. So notice here, I have a known side length across a known angle. And same thing here, I have a known side length, and even though it doesn't look like I have a known angle, I do know this one because of the 180 rule. There's 180 degrees inside a triangle. For the first one, the way it's set up, I could find this angle here because that is the angle opposite 15. And for the second one, since I know all three angles, I could find either side. So it doesn't make a difference. I could be solving for this side or I could be solving for this side, and the sine law will work for that triangle. Here are some textbook questions that you can try. There's 4 of them there. And your book didn't have any with angles, so I've included 2 questions with angles right here. And the answers are right here for those 2 if you want to try them first. Good luck.